Okay, so in this next part, we're talking about graphing lines, and part of knowing what those initial equations mean is being able to use what we know about those equations and translate that into having some graphs for us. So if we recognize what's going on here, we can see that this is slope-intercept form. And how do we use slope-intercept form? Well, what I'm going to do is I'm going to outline slope is 2 over 3. So remember that's equal to rise over run. And my y-intercept is 3. And so how do I use that? Well, first I'm going to use my y-intercept. So I'm going to go to my y-intercept of 3. So 1, 2, 3. And then I'm going to use my slope to find my next point. So because it's rise 2, run 3, I'm going to go up 2 and over 3. Okay? I use the slope to tell me where to go next. And so when I do this, whoops, I'm going to end up with a line that looks something like this. Okay? I know that I'm correct because I've got this positive slope and a positive y-intercept. Okay? That's the easy one. Not that this next one isn't easy, but what we're doing can be a little bit more complex because of the way the equation is formulated. So let's remember what we've got here. This is known as point slope form. And what we have in this one is we have a point and the slope. Okay, so here's our point. It is going to be, now, be very careful here. The formula tells me that what I subtract is what the x-coordinate is. So this x-coordinate is going to be 1. My y-coordinate is whatever I'm subtracting. So because this is a positive 3, that's the same as subtracting a negative 3. So my point is 1, negative 3. My slope is what's out front of my parentheses, so that's negative 2. Okay? And so what I need to do is I need to plot my point and use my slope again. So here we go. My point is 1, negative 3. Okay? And then I go and label it so that we know what's going on. And our next part is going to be a little bit trickier, but not too much trickier, because now we just need to use our slope. So we're going to go down 2 and over 1. And we connect the dots. Nice and simple, right like that. Okay? Guys, it's all about putting that first point in there and then using the slope. So once you know where to start, you're good to go after that. What about x equals 3? When we plot x equals 3, we are going to go to where x equals 3. Well, it equals 3 here. It also equals 3 here. Also equals 3 here, and here, and here, and here, and here. I'm going to connect the dots. So this x equals 3 is going to be a vertical line. Okay? A vertical line of x equals 3. It's pretty straightforward when it comes to the vertical and the horizontal. Okay? Last couple here. See if you can do this one on your own. See what you think. What is the form? What's the slope? What's the y-intercept? Things like that. Okay? I'm going to keep rolling through it. This is going to be slope-intercept. And my slope is going to be 2. My y-intercept is going to be negative 3. So I go down to negative 3, 1, 2, 3. I go up 2, 1, 2, over 1. I'm telling you guys, when we're doing these problems, really all it's about is laying out exactly what we've got from our equation and then connecting the dots. Okay, so that's what that one looks like. In general, let's talk about pairs of lines. Parallel lines, if they are a pair, they're going to look like this. So for example, I could have y equals 5x plus 8 and y equals 5x minus 4. Slopes are the same. I don't know how else to say it. They've got the same slope. So parallel lines have the same exact slope. If it's 1/2, if it's negative 2 over 3, if it's 6, if it's 0, same slope, parallel lines. Okay? Intersecting lines are going to be like this. Y equals 2x minus 5 and y equals 4x plus 3. That's going to give me different slopes. Different slopes for different folks. What can I say? Okay? Coinciding lines. What does it mean to coincide? Coincide means you're living in the same space. Exact same space. So that's going to be like y equals 2x plus 3 and y equals 2x plus 3. Same slope and y-intercept. It's the same line, that coinciding. They run right on each other, right like that. Okay? So, in example 3, we're going to determine if the lines are parallel, intersect, or coincide. Let's look at this. Same slope. So I'm thinking could be parallel, could be coinciding. Different y-intercepts, so I must say that these are parallel. Okay? What about these next two? One of them is slope-intercept form, the other one is not, so let's solve for slope-intercept form. I'm going to subtract 6x from both sides. So I've got negative 2y is equal to negative 6x plus 10. Divide by negative 2 on both sides. Y equals 3x minus 5. So I'm going to solve for slope-intercept form and realize that they are the same exact line. So they must coincide. Okay? Last piece here. I've got two of them, and they're both in different ones, different forms. If you want to go ahead and try this one on your own, that would be a great idea. I'm going to go ahead and roll right through it. I'm going to solve for slope-intercept form. See if you can too. Okay? Subtract 3x. Subtract 3x. So 2y equals negative 3x plus 7. Divide by 2. Divide by 2. I'm not scared of the fractions here, guys. Okay? I'm feeling really good about it. And it's okay to leave these in fractions because if we have these fractions, we can see if they're the same as far as the slope and the y-intercept are concerned. So now I'm going to solve this next one. I'll just divide both sides by 3. So I have y equals 4x over 3, so 4 over 3x, plus 7 over 3. This is what I'm looking at right here. Same slope? Nope. Different slopes? Yes. Same y-intercept? No. So these must be intersecting lines. I've got a thing for the exclamation points today because I'm just excited because this is review for us from Algebra 1. This is review from pre-algebra, and we're rocking it right now. Nice job, guys. We'll see you next time.